5, spring 2025. We're gonna solve this test right now. This is the test. Number 1, in 2020, an organization surveyed 500 Democrats and asked, have you been to a Black Lives Matter protest? Of the 500 Democrats, 440 said yes, 600 Republicans were asked the same question, and 500 said yes. If you were doing a hypothesis to test whether or not the proportion of Democrats who attended was higher than Republicans, that blah, 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 what would the null and alternative be? Write this, H sub 0. Yeah, this one is 11.1, right? This is 11.1 because I can tell that it's proportions. It's 2 samples proportions, I can tell. So watch when I write this null and alternative, you'll be able to tell. Watch. H sub 0, watch, put H0, colon, my son's name, my future son's name, P1 equals P2. Enter, go to the next line, shift enter. Actually go back and do shift enter because I like how it goes right below it. And then H1, colon, now higher, PP1 greater than P2, right? Where P1 and P2 are the population proportion of, let's see, who was higher? The Democrats higher. So then, yeah, of Democrats and Republicans who went to a Black Lives Matter protest. Done. Because notice that it just says, what would the null and alternative hypothesis be? And it also says, make sure you define the parameters if appropriate. So you notice that we're done with the question? Next question. You could say respectively. It's actually good to say respectively. What would the p-value be? Notice this is a numerical answer question because it's small. It's not a big thing. So I just want a number on this one. So what we're going to do is go to StatCrunch and we will plug in, go to stat, proportion stats, to sample. Which one? Summary, with summary. Now sample 1 is Democrats, right? So how many successes are Democrats? How many people went? 440? And how many Democrats were there? 500. Now go to sample 2. How many successes for Republicans? 500. And then how many Republicans were there? 600. Now what should I put right here? This is always 0. Don't ever change it. What should I put here? Greater than. And then press compute. And then we'll get a p-value of what? 0.014. It says round to 3 decimals, so 0.014. In this question, we have this. It's a summary of the proportion data. It's 2 proportions, so stat, proportion stats with summary. We have to know where to go for each question, right? Next question. Would you reject the null hypothesis? Yes or no? No, because the go up, the p-value is 0.014, right? It's too big. So we say no. See what I'm saying? So go to no, false. You would reject the null hypothesis, false. Go down. We can't conclude that more Democrats went to BLM protests than Republicans in the population, can we? True, we can't, because we failed to reject the null hypothesis. So they're equal. The number of Republicans and Democrats that went to the BLM protests is equal. Because if we would have rejected that null, then we could have said more Democrats went. So that's like a conceptual question to make sure you know what happened, right? Number 5. It looks like paired data to me. Because how the numbers are like above each other like that. It looks like paired data to me. Is it the same people? Yeah, 8 people. So it's 8 people. So they're measuring their SAT before and after some prep course, right? So it's paired data. That's it. This would be 11.2, correct? Dang, we have to plug this data in? That's annoying. We have to plug it in. And then I'm just going to, well, okay. What is it asking us to do? Scroll down in the question. Okay, so it says ABC. What's A? State the null and alternative and define the parameters if appropriate, right? Okay, go to the question and put H0 colon mu D. M-U-D. M-U-D. Yeah, I'm not. Mu D, just M-U-D. M-U-D. I like mu. Equals 0. And then go shift enter. H1 colon. Let's see. Mu D. We have to figure out what it is. Scroll up a little bit. What did it say? Oh, does it improves? It improves. So then it would be greater than, right? So greater than 0. And then, my bad. Above that, put A. You should be organized, right? Or lowercase a to match what they have up there. And then go below that. Now, it does say to define the parameters also in that. So we should say where. In part A, we have to say where, right? That's part A. Where mu D is the what? What does mu D stand for? Population mean of the differences, right? Population mean of the differences between SAT scores before and after the prep course, right? Now, part B says to get the test statistic and p-value. So watch this. Stat. Where do I go? T-stat. Thank you. T-stat. And then where? Paired. Yep. You got it. One, we'll put what? Are we doing... Don't we want improved minus old so they'll be positive? Improved minus old will give us positive differences, right? Improved top, improved. And then bottom old. And then we could do greater than. Press compute. And there you go. Now screenshot the test statistic and p-value, and can you paste it in for me? Paste it in there. Yeah, that's part B. Yeah, you could do old minus improved and then put less than. Yeah, that also give you the same. That would give you a negative test statistic, but the same p-value. And then since it's a less than, it makes sense that the test statistic is negative. Yeah. Okay, now what else do we have to do in this test question? Part C, state the conclusion. Okay, C. What do we do, you guys? Reject H0 since p-val less than 0.05. Well, I don't know. What was the... And then go up to... What's our significance level? Do we have one? No. So then we'll just say 0.05. I would say reject null since p-val less than 0.05. Now we say that's the technical conclusion. If you want to be crazy and like go for like an extra credit, say technical conclusion in front of that. And then below that but go up a line, make it more compact. Non-technical conclusion. You know, if you really want to go all out and get like to impress me. Burr, you impress me. Yeah, I know, but put what? There's sufficient evidence to conclude that, right? The prep course improves SAT scores, right? And that's it. A, B, and C. Next question. In general, as a test statistic gets smaller, you have more evidence to reject the null hypothesis. I would say false. Wouldn't you guys say false? Because as the test statistic gets bigger, you have more evidence to reject the null, right? If it gets smaller, you have less evidence. So I would say, well, false, right? Okay, what else? This is a, ooh, look at it. It looks like chapter 12, no? Test of like independence. We just learned this, right? Okay, so this is what I really wanted to get to, this, because we just practiced chapter 12. State the null and alternative, define the parameters if appropriate. A law was introduced to increase, double to increase. If you, first person to catch that on the test gets extra credit, by the way. Typo, see the typo? If you catch typos during an exam, you get extra credit, but you have to be the first person to catch the typo. You have to raise your hand and say, hey, there's a typo. I walk up and I'm like, oh, okay. All right, so a law was introduced to increase taxes in order to provide free college education. A survey was administered. Is there evidence at the 0.01 level of that different ethnicities view the law differently? You have opposed, no opinion, and in favor. And then you have different ethnicities. Put A, and then we'll say what? H0, ethnicity and opinion are independent. So ethnicity and opinion are independent. And then H1. Ethnicity and opinion are what? That's it. How easy is that? B, find the test statistic and p-value. For this, we have to go and plug it all. Can we copy all that or no? No, do it in bar 2. Just plug it in bar 2. Yeah. And then just move Asian, white, Hispanic. Actually, yeah, I don't know. We got to fix it a little bit. You can copy the top row, put it on bar 2. The top row, Asian, white, put it in bar, cut it and put it in bar 2. Paste it on the bar 2. And then cut everything else and move it over to the left. Cut it and then go over to the left and paste it on bar 1. Yeah. Yeah. So look, do you see how we pasted it? Do you see how we had to mess with it? And like, this one's a little hard to plug in. Instead of access, let's say opinion maybe. Is that their opinion? whether or not they're in favor of the law or something. Now go to where? Stat table, right? Stat table contingency with summary. We don't have data. This is summarized. This is the summary of the data. Now we're going to select Asian to Hispanic. And then we're going to row label should be what? Opinion. And then press compute. And it's going to give us the value and the p-value. Can we copy like all this stuff, this chi-square test stuff? Let's get all that. Paste it in. Boom. We got the test statistic and the p-value. Now, part C, give the expected values. So for this one, I'll go to options edit and then click expected count and then press compute. I mean, it does give the observed and expected here. So the way that I would do it, I would copy this stuff. I would screenshot this thing or copy it, whichever. And then I would write underneath it, I'd say the expecteds are in parentheses. So I'm going to do that later. I don't want it to have too much stuff. That's a different question. It's a different part. It's a different part. So I would say the expected counts or whatever, the expected counts are in parentheses, you know, because the observes are the numbers and the expecteds are below it, right? I would say it. I mean, I probably wouldn't care if you didn't say that, but I like to say that just for extra clarification, you know. Now, part D says which cell contributes the most to the test statistic. So then now for part D, I'd go to options edit and I would deselect expected count and then I would only select contribution to the chi-squared. I'd press compute, screenshot that whole thing and paste it in and then say, and then look at them and let's see which one's the biggest. That one looks pretty big. Probably opposed and black, right? That's the biggest number. So put opposed and black. So you see how we do that? That's how you show your work. And you got to give like a column and a row, right? And then E, yeah, and then E, the conclusion is, well, what was the p-value? 0.0301. Okay. That p-value is pretty low. What was the significance level? 5? 0.05? Oh, shoot. So we failed to reject the null on this one. You got to be careful with the significance level. So then we'll say what? Fail to reject H0 since p-val greater 0.01. And then next line we could say there's insufficient evidence to conclude that ethnicity and opinion are dependent, because the non-technical conclusion is always about the alternative hypothesis. So there's insufficient evidence to conclude that ethnicity and opinion are dependent, because that's the alternative hypothesis. And that's it. So I wanted to do this for you so that you can see how to show your work and what exactly I'm looking for, right? For the which cell contributed the most, you could show your work for that, right? Another question. To determine if the coronavirus affects men differently than women, deaths of both genders were found. Age of men, age of women. Perform a hypothesis to determine if the average age of death for men and women is different. A, this looks like what? 11.3, which is comparing the means of two different what? Populations independently. Independent. These men and women are not paired. They're not paired. They're not connected, right? A, state the null and alternative. H0, colon, mu1 equals mu2. H1, colon, mu1 not equal to. So just put / equal or not equal with the words not equal, whichever you prefer. Yeah, if you want to be fancy, you could, but I would, yeah, not equal, whatever. I would put the equal sign instead of the word equal, though. I don't like the word equal. Yeah, I don't know. Or if you want to be fancy, go in and get an actual not equal to sign. If you want to see how, do you guys want to see how or no? You want to see? Okay, fine. We'll do the fancy one. Go to insert what? Equation. And then relationships. And then get a not equal to. All right, so that's it. We got the null and alternative. Notice that part B says define the parameters if appropriate as its separate part. That's how important it is. It's a separate part, which means it's worth the same amount as everything. Everything here is worth the same amount. So B, go to B and put where mu1 and mu2 are the population mean age of death. Population mean age of death for, no, this one's not about differences. Population mean Age. Do we say age? Age of death for men and women, respectively, is mu1 men. Doesn't matter. It's a two-tailed test in this case. Doesn't matter which one is what now, because it's a two-tailed test, right? And that's it. Any questions on that? C, test statistic and p-value. In this section 11.3, independent means you go to two sample. T-stat two sample, right? So, oh wow, we gotta plug data in. You could go to new data table if you want, or do that. That's fine. Sorry about this. I'll try to. I should edit this test to make the data copyable. 77, 84, 40. Now women, women is gonna be 15, 42, 18, 68, 71. What you talking about? We're good? Thanks. So A, we got it. B, we got it. C, we'll say stat what? T stat? And then two sample, right? And then with what? Data. And then click var1 is what? Men and women. Doesn't matter this time because it's a two-tailed test. And that's it. Yeah, do it again. Stat, T stats, two sample with summary. No, data, right? Then men and women. Is that good? Press compute, screenshot it, paste it in. This is how you do your tests. Notice how we're organized with the A, B, C, right? Go to what's next? D. State the conclusion, technical and non-technical. So what are we thinking? Very, very low evidence, very non-evidential, right? Like that word, non-evidential. Made that up. It's non-evidential. You can tell. All right, what do? We failed to reject. Are we failing to reject everything in this test? Fail. I hope that's not a sign of your guys' grades. Fail to reject. Did it? I know. Fail to reject what? H0 since p-val greater 0.0 what? Do we have a sig level? No, right? So 0.05. Then we say there's insufficient evidence to conclude. Wait, you're not going to go to the next line, or we're just going to do it like that? To conclude that, now you got to think. Ages of men and women, ages of death for men and women are different. Is that good? Ages of death, is it for COVID or something? Yeah, just say COVID. Something about COVID. Ages of death by COVID, maybe right here. By COVID for men and women are different. You have to write something like that, right? And that's it. Done. How's the test so far? Easy? Easy, right? Next question. For a test of independence, as the expected values and observed values sound familiar? Get closer together, you have more evidence to conclude that there is an association between the two variables. False. False. The closer they are together, that means there's no relationship. They're independent. It's the further they get apart that you say that there's a dependence. Because the further they get apart, the bigger the test statistic. The bigger the test statistic, the smaller the p-value. The smaller the p-value, what? The more evidence you have to what? Reject the null hypothesis, which is that they're independent and they don't have a relation. So you got to have all this stuff connected. There's a lot of connections. So yeah. Remember that thing that I did in the notes where I showed you those questions? That's that. That's that, right? But there was multiple parts there, and this is just one of them. So make sure you go back to the notes and look at that. And make sure you understood what happened there. What the heck was that? Wait, go to that again? Can you go to that thing? Wait, slow down. What? Nope. Nope. That's chapter 13. That's chapter 13. Yeah, copy it. Copy it. Let's see what happens. Copy it. Go to StatCrunch. Imagine you have to type all that out. And it's like, and imagine it takes like 20 minutes to type it out. Revenge. Like, how are we getting revenge on you guys? Have fun typing that out for 20 minutes. That would have been well. What question did we get to? We could like finish this later, I guess. Oh, we'll continue on 10 next class. From the top. Go to the top. You want to just kind of review everything? That question's 11.1. The first like couple of questions were like 11.1, right? And then go down to 2, 3, 4, and I think at 5 is where it became 11.2, 11.1. Number 5 is 11.2. Then you got that is just like a general question, conceptual question. And then 7 is a 12.2. And then 8 was 11.3. And then 9 was conceptual, right? 10 was what? Oh, that's what we're going to continue later. We'll continue that later. This looks like 11 or no, looks like 11.3, maybe. 11.3, but the summaries, right? Because remember 11.3, they can come as summaries or data. This is the summaries. Yeah, stop the recording. Signing off.